Very good morning to all. I am Dr.C.Senthilkumar, Associate Professor, Department of Mechanical Engineering, SNS College of Technology. I am here to deliberate about the internal flow, which is laminar, how it takes place in the convection unit. So this is for the third year mechanical engineering students. So in this simple sketch, you can see laminar flow and turbulent flow and how it is tested, that also shown in the diagram. Go to the next slide where we can see topics for the discussion. So defining internal flow, characteristics of laminar flow, heat transfer in internal flow, thermodynamics principles, force convection, problem solving, role of heat transfer, practical application, summary and conclusion. Coming to the next slide, defining the internal flow. Internal flow refers to the fluid moving through a confined space such as pipe, duct or channel. Unlike external flow, the fluid is completely bounded by solid surface, which significantly affect its thermal behavior. So that we have explained in the internal flow in a pipe. So it is also deliberated with the picture. So coming to the characteristics of laminar flow, the laminar flow is a very smooth flow, which is explained in the bend of a pipe internal flow. In the turbulent flow, which is zigzag flow, which is also shown in the diagram. So there is a minimal mixing between layers, making heat transfer highly predictable. The laminar flow characterizes smooth, orderly fluid motions parallel layer. So coming to the next slide, heat transfer internal flow. So when fluid flowing inside the pipe flow, it meets the confined flow. It is a confined flow inside the container. That means it cannot escape outside the boundary. Its boundary is different compared to the external flow. Because the flow is smooth, heat moves from the walls to the fluid primarily through conduction within the fluid layer before being carried away by the bulk motion. So that is the speciality of this. Coming to the thermal dynamics principles. Thermal dynamics involves studying the temperature profile of the fluid as it travels through the pipe. The temperature changes until it reaches fully developed state where the shape of the temperature profile remains constant. So the thermodynamics, which is indicated here, Q equal to HA delta T, which is a well-known equation of heat transfer. This is the Newton's law of cooling. Q is heat transfer rate, H is watts per meter squared Kelvin, and A is surface area, and Ts is surface temperature, Tf is fluid temperature. Ts minus Tf is said to be delta T. You would have seen already in the previous one. Let me come to the next slide. The force convection context. Interlaminar flow is specific type of force convection. It is often driven by an external force such as pump to ensure the fluid reaching the necessary velocity to transfer heat effectively. The force convection context, enhanced heat transfer, external with internal flow, increasing H via flow rate. So this is the force convection. Fan is giving the blow of air which is going faster inside the tube or pipe where it experiences very fastest heat transfer. That is the concept here. So coming to the next slide, problem solving techniques. To analyze the system, specific problem solving techniques are required. Key methods are including energy balance, determine how much heat fluid has going inside or outside the flow process. For that we need Nusselt number, we need the Reynolds number, that all we will take from the fetch from the heat and mass transfer. The role of heat transfer coefficient already we had seen, and again calculating the convection heat transfer is essential for that only this slide. And practical application of this convection through internal flow. Microfluidics, precise cooling in tiny channels for medical or electronic device. Lubrication system, managing heat in oil flowing through engine parts. It's all happening in the internal flow. Chemical processing, heating or cooling sensitive fluids that must remain in a smooth unmixed state. So coming to the assessment question. So the first question is, according to the source, what is a primary focus when studying the thermal dynamics of an internal flow? So the answers are here: laminar flow, heat transfer, and problem solving. The second question is, where does the internal flow typically occur? It occurs at the over the wing of an airplane, in the open atmosphere, inside a pub duct or confined channel, in a vacuum? So the answer would be C, that is inside a pipe, duct or confined channel. So these are the reference I made for preparing this explanation of internal flow. So I thank everyone for patient listening. Thank you very much.